All right, so here you go. We voted today in video lecture, won it by about 70% or so, 65, 70%. So here we go. All right, so the periodic table organization, just the basic organization of it. It's arranged by the atomic number. That those words should sound familiar. If they don't, kind of a red alarm. All right, so the atomic number is the number of protons in an element. So as you move one step from the left to the right, it's going to increase by one proton. The atomic number is going to go up by one. So you can see hydrogen right here with its one, it's got one proton. You go all the way over here to helium with its two. Why does it jump all the way from hydrogen to helium? Well, when you're going with the periods, so the periods are the rows going across. So remember that first energy level of electrons. Does anybody remember how many electrons it holds? The answer is two. Well, that's why it goes from hydrogen over here all the way over here to helium, because helium's inner shell of electrons is filled with two because that's all it holds. So then over here, this period started with lithium. It's got two energy levels of electrons. So going across from left to right, those are the periods, and that shows the elements that have the same number of energy levels. So, the hydrogen period, they have one, lithium has two, then sodium has three, and so on. Keep getting more and more energy levels of electrons, electron clouds or shells, all mean the same thing. All right, so those are the periods going across. So it increases by one proton as you make a jump, from one element to the next. Now in groups, when you're going down, these are the groups. These are elements that have the same number of valence electrons. And the number of valence electrons is the valence electrons that give an element its chemical properties, because it's the valence electrons that are involved in chemical bonding. So for sodium here, it's got three shells. So its inner shell does nothing with chemical bonding. Its second shell does nothing. It's the valence shell. It's the outer shell electrons. Those are the ones that interact with other elements to form chemical bonds. So as you go down, so like here, group one, they all have the same number of valence electrons. Anybody know what it is? They have one. So most of those guys want to get rid of that one valence electron, because if they do, their next energy level down is filled. And that's what all elements, all atoms, they want to do that. They want to become stable. And they become stable by filling their outer shell of electrons. So beryllium, does anybody know how many they have? They have two. We skip the transition metals here in the middle because they're a little different. We'll talk about them later on. So we go over here to boron. They have three valence electrons. Carbon here has four. Its group. Nitrogen, of course, has five. Oxygen has six. It wants two more to get eight. The halogens here, fluorine, they have seven. They only want one more. And over here, you have the noble gases. Remember, helium has two. It's filled with two because the inner shell only holds two. But the rest of these guys, neon and argon and krypton, their outer shell, their valence shell is filled. So they do not want to form chemical bonds because they don't want to gain any more electrons, and they don't want to lose any more because they're completely stable with a full outer shell of valence electrons. All right, so that's the basic arrangement of the periodic table. All right, so one of the three different periodic trends we're going to go over, the first one's ionization energy. And I guess if you want to know what ionization energy, maybe you should know first what an ion is. All right, so ionization is the process where an atom gains or loses electrons, resulting in it having, remember, atoms are usually neutral because they have the same number of protons and electrons. But in ionization, when they gain or lose electrons, this results in them having either a positive or negative charge. So that's what an ion is. It's a positive or negatively charged atom. So why do they want to gain or lose electrons in the first place? They gain or lose electrons to become more stable. So they might want to gain an electron in order to fill their outer shell, like chlorine or fluorine. They have seven valence electrons. They need one more to fill it. So they like to take one from another atom in order to have eight, which makes them a full outer shell, which makes them more stable. And also, some of them want to lose, because if they have one electron, like say sodium, if it loses that one valence outer shell electron, well, then its next lower energy level shell is already full, so then it'll become more stable. So there's basically two types of ions. First, you have cations. Cations have a positive charge. It has a positive charge because it lost one or more electrons. Since it lost one or more electrons, it now has more protons than electrons. Since it has more protons, it's going to have a positive charge, because remember, electrons have a negative charge, Protons have a positive charge. The other type of ions are called anions, and you probably figured out they have a negative charge. Why do they have it? Because these atoms gained one or more electrons. So then they have more electrons than they do protons. So that's going to give them a negative charge. So you can see right here, we have sodium. You can see it's one valence electron right there. It wants to get rid of it. Chlorine right here has 7. It wants one more. Well, they're a perfect match. So sodium is going to transfer, it's going to be ionized by chlorine. So it's going to transfer its one valence electron to chlorine. And that's going to cause sodium here to become a cation. It's going to be positively charged because it lost an electron. Chlorine here, you can see it took sodium's one valence electron. Now this electron shouldn't be here anymore because it got transferred to chlorine. And since chlorine gained an electron, it now has one more electron than protons, and it's going to give it a negative charge. And it's going to be an anion. And if we remember, opposites attract. So this is how table salt is formed. Sodium is an explosive metal. Chlorine is a poisonous gas. But they react together. It's called an ionic bond. They attract each other. The positives attract. So sodium and chlorine, sodium and chloride, come together in an ionic bond to form sodium chloride table salt. So that's an ionic bond. So those are ions. Positive ions, cations. Negative ions or anions. All right, so now that we know what ions are just positively or negatively charged atoms. Remember, cations are positive, anions are negative. So ionization energy is the amount of energy required to remove an electron from an atom. Some atoms hold their electrons really strongly. It takes a lot of energy in order to remove an electron from those atoms. Other atoms, they're holding their electrons, but not really that strong. All right, so how much energy does it take to remove an electron from an atom? So what we need to know is, what are the trends? So as you move from left to right across a period, going sideways, going horizontal in the rows, each time you go over one, so you go from lithium to beryllium to boron to carbon, each time you move over one, you're adding another proton. It is those protons, the positively charged protons in the nucleus, that are holding on to the electrons. So as you move across, you're adding more protons, which means more protons, more positive charge to pull on those electrons. So as you add more protons across, you're going to increase the ionization energy required in order to remove an electron from that atom. Because remember, as you go across a period, you're not adding new energy levels. So lithium, beryllium, carbon, they only have 2 energy levels. As you move across a period, you're not adding more energy levels. So the electrons aren't getting further away from the nucleus. You're just adding more protons. You're adding more electrons as well, but you're adding more protons, which are going to hold on to those electrons tighter. So ionization energy increases as you move from left to right. Now, ionization energy is going to decrease as you move down a group. Now, this one's pretty easy to understand because remember, as you go down a group from like lithium to sodium to potassium to rubidium, each time you move down in a group, now you're adding another shell or another energy level. And each time you do that, the electrons are getting further and further away from the nucleus. And remember, it's the protons in the nucleus that are holding on to the electrons. So when they get really far away from the nucleus, they have a less strong hold. So that's why ionization energy decreases as you go down because the electrons are further away from the nucleus. All right, so that's ionization energy. Okay, I don't know if you're going to need to know this, but I'm going to go over it anyways real quick. Electron shielding, like shield. This is where the inner electrons block or shield the attraction between the nucleus and the outer or valence electrons. So you can see here, we have the nucleus here. It's got a positive charge. So all these little red electrons, they're attracted. They all have a negative charge. They're all attracted to the nucleus. So it's that positively charged nucleus that's holding these electrons here. So we know this isn't the innermost shell of electrons because there's 3. We know that the first energy level only holds 2. But anyways, we'll look at it here. So there's 2 forces. So here's the outer electrons here. Here's the valence electrons. They're further away from the nucleus. So they're feeling 2 forces. So first, these inner ones are only feeling 1 force, an attraction to the nucleus. The negatively charged electrons are attracted to the positively charged nucleus. But these outer ones are feeling 2 forces. They're attracted to the positively charged nucleus, but they're also getting repelled by the negatively charged electrons in the shell that's more closer to the nucleus, an inner shell. So they're feeling two forces. Remember, opposites attract, positive and negative attract, but like charges repel. So negative and negative don't like each other. They repel. Same with positive and positive. So electron shielding is where inner electrons, they repel the outer electrons, which causes them to be less tightly held by the nucleus. And what does that result in? Since they're not held as strong by the nucleus, it's going to result in lower ionization energy. It's going to make these outer electrons, it's going to take less energy in order to remove one of those electrons from that atom. So that's electron shielding. Okay, atomic radius, my favorite one because it's only one slide. Atomic radius basically says what it is. Atomic, atom, radius. Radius is the distance from the middle to the edge of a circle. So it's the distance from the nucleus to the outermost electrons. All right, so we need to know the trends. Now, as you go across a period from left to right, you're adding protons and you're adding electrons. So you would think the atom would get bigger, but you would be wrong if you thought that. Because as you move from left to right, you're adding more protons. You're getting more protons and you're not adding more energy levels. You're just adding more electrons into that energy level. But it's the protons that are pulling the electrons towards the nucleus. So as you add more protons, you get a stronger nuclear pull. So more protons means the electrons are more attracted to the nucleus, and the nucleus, the positive protons of the nucleus, are pulling the electrons closer and closer and closer as you move across a period. And you can see that here with these orange little balls. As you go from lithium to beryllium to boron, carbon, nitrogen, oxygen, fluorine, they're getting smaller and smaller and smaller because there's more protons pulling those electrons closer and closer and closer to the nucleus. And now going down is even easier. As you go down a group, so this is the alkali metals right here, lithium, sodium, potassium, rubidium. Each time you go down a step, you're going to add an energy level. So you can see lithium here with its one valence electron. They're all in the same group, so they all have one valence electron. So they're all going to have similar chemical properties. But each time you go down a step, you're adding another energy level or another electron shell. And as you add another shell, of course, the electron gets, or the atom gets bigger and bigger and bigger. All right, so that's atomic radius. All right, our last slide, electronegativity. Now, good thing is this is almost exactly like ionization energy. It's very, very similar, but it's not how much energy is required to remove an electron from an atom. It's an atom's ability to attract electrons when it's in a chemical bond. So when it's bonded with another atom. So electronegativity, some atoms attract electrons more than others, and it has to do with more protons. So if you have more protons, you're going to have a stronger pull on the shared electrons. In a covalent bond, that's what it is. You have two atoms that are sharing electrons. So you're not forming ions. Remember, you form an ion when an atom loses or gains an electron. In a covalent bond, they're not losing or gaining electrons. Both atoms are now sharing their electrons. You don't need to know covalent bonds that much yet, but in the future we will. So once again, the trend is, I wish I had a periodic table here, but I don't. It's just like ionization energy. As you move across a period from left to right, ionization or electronegativity is going to go up because you're adding more protons. And the more protons is going to have a stronger pull on those electrons. And just like with ionization energy, as you move down a group, electronegativity is going to drop because the electrons are now further and further away from the nucleus. So there's going to be a weaker pull on those electrons. So you can see right here, this is a covalent bond. So this is, I can barely read, it's an F. So that's fluorine. It is the most electronegative atom. It has the highest electronegativity of any atom there is because it's in the top right. Because remember, as you go down, electronegativity goes down. So as you go up, electronegativity goes up. And as you go to the right, electronegativity goes up. Well, fluorine is located in the top right next to the noble gases. But the noble gases don't form chemical bonds. So fluorine has the highest electronegativity. So it attracts electrons more than any other atom when it's in a chemical bond. All right, so that's the trend. As you move left to right, electronegativity will go up, just like ionization energy. And as you go down, it's going to decrease because the electrons are further away from the nucleus, means a weaker pull. So There's also something called a polar covalent bond. I don't think you're going to need to know it yet, but here's water. Here's water. So oxygen has a higher electronegativity than hydrogen does. So H2O, that's water. So they don't share. So here they are. They're sharing 2 electrons here, and they're sharing 2 electrons here. And when they form these bonds, they're doing these bonds because by sharing these electrons, it's giving oxygen a full outer shell of electron with 8, and it's also filling hydrogen's outer shell of valence electrons with 2. Because remember, that first shell only holds 2. So this is a very stable atom because oxygen has a full outer shell, and so does hydrogen. That's why they form these chemical bonds. But they don't share the electrons equally. Oxygen has a higher electronegativity. So these electrons are going to be drawn closer to the oxygen. And what does that result in? It's going to result in what's called a polar molecule. Polar doesn't mean it's cold, doesn't mean it has white fur like a polar bear. It means it has a negatively charged side and a positively charged side. And the reason this molecule is polar is because oxygen here is higher in electronegativity, so it's drawing the electrons closer to it, thus giving this side of a water molecule a negative charge and the opposite side, the hydrogen side, a positive charge. All right, I hope you guys understood it. Quiz time coming up on the Ed Puzzle, and I'll talk to you next time.